No, you can leave. Okay.
Makes it a little harder for him to.
It is. The AC kind of looks like. I haven't seen cages. Probably took it off the line.
Okay, does everybody understand how an AC system works? It's pretty simple when you look at most of it. So sometimes you have a receiver dryer here. And sometimes you have an accumulator over here. Now, you don't usually have both the accumulator and receiver dryer. This is a compressor, obviously. Okay. So when this is full of Freon, we probably have Freon. This is the cold side. So Freon comes from here. As soon as it hits this restriction device, it gets cold. It goes out to about right there. Goes back through the accumulator, back to the compressor. And at this point, right here, it gets hot. And it's hot, 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 and then it gets cool again. And it starts getting cool. And it goes through there, cool, up to that point. It's like 100 degrees. Then it goes past through here, and so we have the pressure over here on the high side, which is the gauges, high side, low side. So on a normal operating system, the receiver, or the low side, or the high side would be about straight up at 200, 250 PSI. And then there's a boiling point on that as well. Low side is about 38 PSI. And that PSI depicts what, if there's liquid or if there's gas inside that line, based on temperature. Does everybody understand that? Not really. I'm gonna draw a stove and a pressure pot here with water in it. And this has a thingy sitting here with a big old ball on the top of it. None of you ever done, mom's ever done canning. It has an opening on the top. And that, based on the size of that opening and the weight of that ball, it puts like 5 PSI inside here. Does that make sense? You got fire here burning. Fire's heating that up. So this in this case is just water. To understand this, you kind of need to understand this. This will make it make sense. Right, Jeremy? Okay, hopefully. All right. So this is water at 0 PSI or sea level. As me and Asa knows, the PSI goes down as you go up. At 0 PSI, water boils at what? What's water boil at?
100 degrees Celsius.
This is correct. What's it boil at Fahrenheit? Because we're Americans. 212. Sorry, 212, not 210. As pressure goes up, what happens to this? As pressure goes up, what's the boiling point do in water? Goes up higher? Okay. So 5 PSI goes to what? 240 probably? I'm guessing there is an actual formula and a graph that you could go on Google and I'm sure it would give you the answer. So 10 PSI, it would boil at, let's say 300. I don't know if that's right, but that's gets you the idea. 10 at 300, 0 there, 0 there. Okay, so what if we had this water at 10 PSI, it's 300 degrees, And all of a sudden, this thing gets a hole in the side of it. No longer, so it goes to 0 psi, and it's 300 degrees. What happens?
It boils off.
Water boils and
Instantly boils off.
steam.
Steam. Goes from a liquid to a gas. Okay, makes sense? And how low is it going to do this until it quits boiling? This is opened up. How low is it going to go before 300 degrees Fahrenheit? Or- At 0 psi, it's going to go back 212, right? It's going to go right back 212. So if I had that simmering on the stove with an open top, could I tell what temperature that water is? I got a pot open, it starts boiling. What temperature is it? We always know that, right? That's cool. Why can't we apply that over here? Can. It's exactly the same. Freon boils at, did you go get me the AC gauges? Wherever they're at? I need the set that's up there. Freon boils at 0 psi. It boils at negative 14 degrees Fahrenheit. That make sense? This is our ratio over here. 0 psi, 212 degrees. Freon, 0 psi is negative 14 degrees Fahrenheit. You can punch the Schrader valve, nothing happens. It's basically like you could open that, nothing happens. This is what made sense to me a lot. Is on this gauge, it has a Fahrenheit right here, and that's the boiling point of 134A. So if you want maximum cooling out of a vehicle, you don't want it to freeze over inside. So how low can you go? Well, 32 degrees on here, 32 degrees Fahrenheit is 30 psi. So I could go down to 30, and this would be 32 degrees. That make sense? I don't know why I drew a line there. Make sense? If this goes down to 28 psi, what happens? It's 30 degrees. Freeze. As it drips on there, it'll freeze, and eventually that'll become a block of ice, and you won't get any airflow out of the vents. Anybody ever have that happen? Yep. So they do a couple ways to regulate that. One way is, since we know pressure and temperature is very related, one way to do that is put a pressure switch right here on this side. So that's the orifice device. Put a pressure switch to the HVAC module or the PCM. I think it's PCM usually. Anything below, what did I say, 30, anything below 30, that shuts off. It opens. It goes open. So less than 30 psi. And it shuts that off, and it lets that warm up, and it lets that pressure come up as it's rotating. And it will, that's one way they do that. Another way is they put a probe right here, temp probe. And anything below, 33 degrees Fahrenheit, they cut the compressor. Okay. That makes sense. The compressor, everybody knows what it does. It's a pump, and it pumps it around here. Same thing over here.
You got one evaporator that's freezing up, you really have two pumps, you're low freon and you got a bad cycle switch.
Well, it depends how it's working. If it's freezing up, you have either this is bad or this is bad, right? Because if it got low enough pressure, she'd shut it off. And as long as that pressure stays at 30 degrees, it doesn't matter if it's on the intake or the outside, anywhere in there, it can't get lower than that, because if you take pressure away from this, what happens to the boiling point? It goes lower. So if you keep the pressure up, it has to be up there. Has to be. The thing I like about it is it's absolutes. Water boils at 212. There's nobody that can really change that unless you add something with it. Now, if you added air into the AC system instead of Freon, you probably would change some things. Same thing up here, they use a pressure gauge over here. So they use like a pressure switch, I guess. Oh, like this, PCM, to run the cooling fans. And this usually goes on, what, low at 250, high at, low at, it goes on to high at 250.
Yeah.
250 PSI. And 250 PSI on here is, Fahrenheit is 140. Degrees Fahrenheit is where the boiling point is. So, does that make sense? Gets too hot, it cools it down. If you cool this down, what's going to happen to the pressure? If you cool that water down, turn the stove off, what's going to happen to that pressure? Go down? Okay. Same thing happens here. Your low side is too high, it could be overcharged. But also your cooling fan might not be working right. It might be just on Cummins, it sits there and goes boom, 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 boom. Pressure side just goes, high just goes, keeps going, keeps going, keeps going, keeps going, keeps going, because that guy don't come on. Jeremy, does this make sense how it transfers over to here now? So could I tell, so this is, so when it comes out of the compressor, it is a gas. It's like, it's an air, gas or air. And it up here, what is it?
Liquid. Right there's a liquid.
What is it right here?
It's here.
That's a gas.
It's a fog.
No, it's a fog.
It's like, it's boiling, boiling. Right? So, Wesley, why do I always grab the large one coming out of the cab to see if it's hot? See if it's cold?
Large, that's your low side. It's going to be the one that gets cold.
It should be cold. What if it's low on a charge?
Depends on how low. You can have them
Pretty low.
pretty low, and then usually it's warmer. It's not real cold.
Okay. Why is that? Is that because this stuff coming out is not, it's only cooling like maybe this much of the evaporator. It's not really actually cooling anything coming out, so it's just dribbling a little bit in. And at that point, it boils it off. It did not put enough in to keep the whole thing boiling.
So you don't get like cool on the outside. It
Yeah.
basically dissipates the heat too fast for you to feel the cool on the outside.
Right. So that's where I always check them right there. Just grab onto it. Needs to feel like an ice cube. You can actually charge this way. If everything else is working right, you can charge the system and grab there. As soon as it starts feeling like an ice cube, quit. No more Freon. That is not professional advice. Don't do that at home.
You can't do it.
I've done it a lot of times, so that's about the most accurate way. But yeah, do not go to AutoZone and get your own little thing and
See,
charge it because it'll probably cost you $1,000.
when I used to charge on scales, we used to do it on the Fahrenheit. We bring it to 33, 34 degrees, and that's where you stop at because
Right here?
Yeah, on the what you're doing, just
Yeah.
watch and go low side. Nope, that's at that point you got the thing is cold as it can be without
Yep.
freezing. And sometimes it's actually less refrigerant than it calls for if you actually weigh it because less actually will bring you colder to a point.
Yeah, that's the point. So there's multiple different, some of you guys all know this stuff. There's multiple different expansion valve things. Jeremy, you were in the exact class of the description I gave this in. Or I got the toilet float. Remember that class? It was up there by, no, it was Elkhart by 933 in a hotel. I remember you were there. TXV, thermostatic. Let's go orifice tube. Okay, everybody know what an orifice is? Comes down, gets really tiny, really small, goes big again. So if we have flow going this way, we can have 200 PSI here. You have 32 PSI here. Make sense, all you young guys? Make sense? I want you guys to ask a lot of questions because that's the way this works good. That's an orifice tube. That's where those little blue things, those little white and blue and yellow things you pull out. That's what that is.
Is the hole or is the diameter
There's different.
between those chambers different?
Yes.
Some of them, there's a blue one, there's a white one, there's a green one.
There's a variable one that was awesome.
Yep.
Retrofit.
Yeah.
Well, I mean, like that one orifice right there, where it says 200, is this one 0.5 inch, and then this one's 1 inch?
I don't know. This is just this is the illustrated orifice. It's not definitely not to scale.
Well, what I mean is,
Hmm?
that's not designed to make the process happen. The reason it gets cold is because that smaller.
Yeah, because it goes from a high pressure. It goes from having 10 psi in the system to, or 200 psi because it's just a difference in the liquid we're actually boiling. It goes from 200 psi to 32. What happens when I cut this and let the gas go off at 300 degrees and 10 psi? If I let the 10 psi out, it goes to boil and it comes back down to 212, right? Same exact process happens here. Different temperature chart, that's it. Same exact process happens. Also, if we kept pumping really moist, air in here with the compressor, well, literally the compressor, you know how you drain the water out? Why is that?
Condensation?
Condenses. Wonder why it's called a condenser. Because it rains inside. You would basically be making rain in here. If you put, shut that off and put a pump here. So go to 200 psi. Kept pumping it in there and keep it cool in this, making it 20, let's say 35 degrees. Kept pumping stuff in there. It'd eventually get full of water, right? In theory. That's the way this works. So this is a gas. This gets cooled down, and it comes out a liquid. Make sense to everybody? Do you guys get that? Kind of? Ish? Do you have any questions? You guys have any? So that's an orifice tube. You guys understand that? That's what keeps 200 psi over here, is it can't get to 32 psi easily. Make sense? You need to go somewhere you look like you.
Need some water?
Hey. This class may be over. Okay though? Alright, so
The man's dying over here.
You're just taking
Thank you, sir.
your time, man.
I was just faking so you get a water for me. Thank you.
He stopped and took a pee.
Checked out bad year where you did with this.
Does that make sense for everybody? Okay, so I'm going to try to draw a toilet float here. You guys know how a toilet float works?
I watch mine every night.
This is a float. This is the, we're going to call it Freon. This is the line that comes in, goes right down to there. We're going to say we have a seal there. So this is where it goes out. I'm drawing this right here, just so you keep in reference.
The evaporator?
I'm drawing the evaporator. Let's just say this is an evaporator. Freon, so this is liquid. Comes in. What happens when, this is basically, instead of a float, it's actually temperature, but we're going to use a float for an illustration. What happens as this level gets down here?
The more liquid comes in.
What happens right here? This thing goes down, this is blocking it off right here. It opens up and it goes in here, right? And this regulates where that level is. So think of this as the temperature. Say that's a temperature, it regulates that temperature. And this comes out here, as this would be in the pressure cooker. It comes out here in a gas. Or I think of it as air, like we breathe. So, if it gets warm, too warm coming out, the float will open and it'll let more cold fog in, or boiling Freon in, until it gets cold enough, and it regulates what comes out. So it regulates this, let's just say 35 degrees Fahrenheit. It regulated. Does that make sense? This is called a TXV, or a thermostatic. Thermostatic expansion valve. That has I'm pretty sure that has a regular orifice tube in it on that car. The Jeep's probably got a thermostatic expansion valve. The Chevy back there's got an orifice tube. That I know has a thermostatic expansion valve on the F-150. Not sure what's back there, but. So some systems, like the stupid Astro you had in here, or the really nice Astro you had in here this morning, it has both. It'll probably have this at the back, I believe, and it'll have an orifice tube in the front.
It just had the front.
Okay. Well, if they have both, they do that. Anybody have any questions about this?
So I've looked at TXV valves, and they have that diaphragm on the top, right? And then that little needle that goes through. So does that move?
That needle, yeah, as that temperature comes out, it watches that, and then basically you have an H block is what it is.
You have a little guy in there watching it?
The comparator is probably something else. So you have, as this little needle goes one way or whatever, it keeps here, it comes over here, and as it needs more, it goes that way and opens more. Does that make sense?
Yeah.
It's an H block. That's how it works, though. That's the little H block with two
So it's
things on it.
mechanical.
Yeah, it is mechanical.
Kind of like
Based
a
on-
thermostat.
Yeah, thermostat. I mean, it is really a thermostat, kind of. Never really thought about that before. That's like a thermostat. As it needs more, it lets more in. What happens if this is coming out at, I'm going to start throwing some scenarios here. Let's say this is coming out at 50 psi, 50 degrees Fahrenheit coming out. The pressure over here is 50 degrees Fahrenheit there. The pressure over here is 110. The pressure over here at 50 degrees Fahrenheit would be, I guess it'd be 55 psi. Which that would cool if it was 90, but if it's like 75 out and you want it a little colder, or 80, it's gonna suck. It's gonna suck bad. So what would be wrong in this case if we had, on the high side gauge it says 110, low side gauge says 55. What would be wrong, guys? It could be a compressor. What's typically gonna be wrong in our shop though? Low on Freon? Why? What makes it low on Freon?
High size, man.
My size not where it needs to be.
Yep.
Unless it is a true back compressor, that's
Yeah, it could be a vacuum compressor, but 99% I would say the time it's low. So what's happening here? This comes out of here, and there's not a lot here. There's not enough to compress really, so it doesn't have to work very hard. Is this cooling fan going to be on high?
Nope.
It'll be on low, if it runs at all. So it goes over here. It's only 110 psi, and not a lot of psi. It's cold, but then it doesn't have. Well, if it was low, this side here would be low. It would be this psi, but it would be low. It would be like it would be short cycling, right?
Right.
You would go to 55 and shut off. You would go to 55 and shut off. Yep.
Well, part of it would be because this here would be all the way open, trying to get more Freon in there, but it's just not coming. Any Freon coming in to cool it, so it's cold going out. Basically, you hold your finger on the big line and it's warm. Now, what happens if this guy doesn't work? What happens then? I want some of these young guys to tell me. What's my pressure going to do if this cooling fan right here, or right here, I guess I should say, if that guy does not run? Why is he going to go higher? Can you tell me why it's over here on the water? Andrew, why?
Because it was high pressure.
High pressure?
I mean, it's still higher pressure.
Yeah. if let's say you had a car in here and you wanted to see if the AC worked good outside of the cooling fan. So if I replace that cooling fan and get it working, it's going to work perfect. How would you test that? Test all the rest of the system so I know that that's the only problem it has. Ice cold if I fix that. I know what you would do. What would you guys do? I'm looking at you for. You guys should teach this class. What's a way that you could cool the, your goal is to cool this down so the pressure drops, so after it goes through the orifice tube, it gets cold, right? That's not happening, because this doesn't work. What would you do? How would you cool that down? All you have to do is cool it down. How do you cool something down? That's one way, another way. Okay? What do you do with the wheel bearing when it's hot and you gotta cool it down? Shoot water on it, take it out back, watch your pressures. Pressures go in line and it gets cold, you're good. Cooling fan will fix it for sure, done.
That's when you tell Dodge Cummins, clutch fans, and all that other crap. Spray it.
If this thing's over here at
Don't know if them things are pulling good enough or not.
if this thing's over here at 400, and you shoot it with that thing there and it comes back to 250, you know that's going to fix it. And if it gets cold inside. What else is common issues? Well, we didn't quite go over all the stuff that's in the system, but I want to make sure this water makes sense to transfer into there, because that makes sense to everybody. Make sense? Does it make sense to you? Kind of? If you were trying to cool something that was 700 degrees, you literally could use water. Because the temperature that you're trying to cool is so much higher that you could actually use water. That's why they have to have something that boils at negative 14, because they're trying to cool something down to 32 or whatever. Does that make sense how that transfers over there?
Yeah. No pressure.
So here's what I did to Jeremy, and he didn't really understand. I don't know if he understood this or not, but he was like, what do you mean it's exactly that? Anyways, he told me, let's say Jeremy told me, yeah, I have 42 PSI. And I said, hey, 42 PSI. I can tell you that the inside cab temperature of that condenser is going to be 48 degrees. Temperature out the vent is going to be 58 degrees. How do I know it's 58 degrees if you got 48 degrees on the low side? Just, it is. It's, you get a 10 degree drop of, what is that called? Thermal efficiency, probably. I'm not a professor, so I don't know exactly. But pretty much whatever your low side boiling temperature, pressure is, I don't even have to go inside and look at it.
It's like your AC after taxes.
It's like, that is an awesome analogy. That's your AC after taxes. That's amazing. That's awesome. Never really thought about that. That's perfect. Okay. Now, what else could creep that up? This I'm going to throw into you guys once in a while. Let's say everything on the system, there's only one part broken, and that's high. Yep. So it went from, let's say, I'm thinking Chevy pickup, Chevy Suburban 2005. Low side should be, let's say low side should be 38 degrees, 38 PSI. And it is 48. And it's not cooling very good. And I'm just going to tell you, I have the correct charge in that vehicle.
What's it sitting?
So there's something that will increase that PSI by 10 PSI or 10 boiling points degrees.
But is the truck sitting or is it?
Sitting doesn't matter. Let's say I sit in the bag, that's when it was. I had this on the truck.
What's the high side? What's the high side?
225, 250?
So it's okay.
Yeah. What will raise that 10 PSI?
How about a cabin air filter? You don't have air filter.
Cabin air filter wouldn't raise it.
Wouldn't raise this if you
No.
had less air coming across.
It would make it work. What would make this here work harder?
Would it be a restriction in the accumulator?
No. I'm just gonna say, this entire system is good and where it should be.
Wrong orifice too.
What?
Wrong orifice too.
No. That's not what I'm looking for though.
Oh, it's backwards.
No. We had one of those.
I'll bring this number.
Oh, we're in class. I'm so
We
sorry.
are in class still.
I had an alignment.
Okay.
Which I couldn't think about that.
What happens if you make this work really hard? What happens if you warm this water up? You warm that water up, what happens? What happens to boiling point?
It turns into gas.
What happens to temperature?
Races.
You raise it, what happens to pressure at the same time? It goes up.
Does that react too much oil sometimes?
No. It's gonna make really easy sense when I say what it is.
Is there a hole in the system?
No, everything's good. The entire system is good.
Oh, you said the entire Chevy?
Yeah, it's a Chevy. If I apply more heat and make this work harder, what would make that work harder and raise that?
Compressor over pumping?
Well, kind of hot air. Keep going. Recirc door don't work. It literally, the recirc door, because it's making this, it's keeping this warmer because it's getting hot, moist air in instead of cool and recooling the cool air. That will raise it 10 psi on the low side. Recirc door that doesn't work. It's staying in outside air. Make sense?
Where's that located at?
What?
Where's that located at?
It's on the intake. It either takes inside air or it takes outside air. It's kind of like the carb heat on an airplane. Yeah. Under the passenger airbag. Good answer there.
Where you don't want to know.
Yeah. Most times you don't know. But I've had that multiple times. If something is 10 psi too high, that's one thing you can look at. Because you know when you start that car up there, let's say it's 80 degrees in here, the low side is going to be high, and then that low side is going to creep down as the inside of the car gets cool, right? And creep down to like what we want, like 36 psi or whatever. Same thing happens with that. It's making it work hard. The reason that doesn't start there and doesn't start at 38 psi is because it's keeping this too warm. Cabin air filter would actually make that freeze. Yes.
Correct.
Yeah. Cabin air filter is plugged to make it get colder. You'll have cold air, but there won't be a high volume of it, so it won't cool the car very good. And that PSI should go down. Hondas, Toyotas, amazing AC. They also have really low, fine pressure on the low side. Like it'll be boiling point of 33, dip into 32, 33 on a Honda Fit, Honda, those little cars. That'd be good. The biggest thing I wanted to get Jeremy's, did I make your mind? Because I've always tried to explain this to you, you never said it made sense.
Well, we never really
Drew it out.
ever sit down and go over it.
Yeah, we went over for like 5 minutes road rush and then we're done. Does
Yeah.
that make sense though? So if you took a temperature gun and you went down through here, let's say we don't have 400 psi in there. Let's say we have 250 psi, and I don't remember what the temperature of that is. 250 is 180, 140?
140, right?
140, that sounds
Right,
kind
it's in the red right there next to it.
Oh yeah, okay. So let's say we have 140, but it's going to come off of this compressor in a gas, and it's going to be 220, let's say. If I had a temperature gun that could accurately go along this line, could I tell how full this was of liquid? Good, good.
Watch your
Yeah.
start.
If I went up here and it's 400, 400, 400, 400, 400, 400, 300, liquid line's right there, right? Same thing with the front of the car. As it goes in, right here, 200, 200, 200, 200, 200, 150, 140, 140, 140, 140, that's all full of liquid. Now there's something else that they've put on, I don't want to erase all that, but I'm going to draw, I'm going to draw both sides of a system like that. Pump and TXV here. Hyundai's and a couple other of them, I've seen them do this. They super cool this liquid. Have you guys seen them do that? Yeah, they take this here and they wrap it around here and they make it go like this. Do they do that? I haven't seen very many. I know Hyundai's do it. And they come up here like this.
Yeah, they're on newer Fords too.
Are they? It super cools that, so when it goes through this orifice tube, it has a lot of cooling potential. Make sense?
Why would they do
It's like starting this off.
Already.
at 40 degrees instead of starting off at 212. Why would they do it?
Yeah.
It works really good. There's a lot more thermal potential in that Freon when it goes through that TXV to cool that. That makes sense? Illustrate it. Hot, and kind of there it turns cold, and there it gets really cold. This little guy over here, he is freezing because he's so cold. All right? Does that make sense?
So is that, would you do that so that your compressor operates less?
Well, it does two things. Let's see, so you got cold air coming here. I guess it would make the stuff that goes into the compressor actually hotter because it's a radiator, high and low pressure. It would make this hotter, so it makes this end get hotter and this end get colder. Make sense? Have you seen those, Jeremy?
Yeah,
They're pretty cool. When I realized what that was, it's pretty neat.
what they use on the Hellcat. Inside the intake manifold, they turn the AC compressor on. As you pull up the line, you hit a button, super pulls the intake charge.
Oh, there you go.
So you drop your intake
Yeah.
air temp by 100 psi.
There's one
Two
call.
step, pull your wheels and go.
We can go over some more stuff with this later. We got the water theory, the super cool. That's that thing right there. We're super cooling the Freon so it has more
I
thermal
think those are
potential.
called manifolds, right?
I don't know what they're intercooler. I don't know.
Yeah.
I don't know what they're actually called. Do you know? Anybody
AC
know?
manifold or something.
Maybe AC, I think that rings a
Might be.
bell. AC manifold.
Variable volume. We did that. Accumulator, receiver dryer. We did the compressor, evaporator, condenser, orifice tube, and thermostatic condenser valve. We don't have any more time. I mean, I guess we could go a little longer, but somebody's got some stuff to do. We'll go over the rest of those next time. I think all the other guys understand it. It's not going to be later. Cool, cool. Thanks for listening to me, Jabber.